Hello and welcome to my second video for going over Godot. This morning I've got some pretty cool things to show you, I think. So last time I had my little guy simulating signals and emitting signals and listening to signals between objects in order to show a pulsing animation. I've since scaled it back and tried to focus on the basics of the system that I'm working on. And so I just started with a simple heart. So I just decided I would just look at this, and this is the first situation. So this is just a heart, it beats, that's it. And then I scaled up the functionality and created an attacker that attacks anything it's attached to. So this attacker, if we look at the code for this, here we go, is just a simple node, doesn't have any graphics or anything like that. And what it does is it just, every 200 frames, it's going to just emit a signal on the parent that it's attached to. So I think it's like every second-ish that it's going to do that. And then after that, the heart itself will connect to itself, which is an interesting technique I've figured out. So the idea here is I don't want to have to know beforehand what connects to what, if that makes sense. So right now I could say, hey attacker, you are now directly attached to this. Like for instance, if I went to this node, you can see all the events that are on the heart, for instance. So like the damaged state, the damage event, impulse. I could say, okay, let's just connect this to the attacker, and vice versa, and then it'll just work that way. Instead, I'd like to just be able to put something in as a child to a parent, and it'll just affect the parent, and then the parent can manage the effects of its children in that way. So what this means essentially is you can have this functionality if you have the event connect to itself, so that when something triggers the event on it, it will process that event as seen here, which is all I do is I subtract down to a minimum of 0, and then when it is at integrity 0, I just emit to its parent that it's been destroyed. Otherwise, I just say it's been damaged. Now, this damaged event is being listened to by this graphic, and this graphic has this impulse graphic script. I called it impulse graphic because it was just impulses at first, but now it's also reacting to when you're damaged. And what this does is that whenever its parent gets damaged or fires an impulse, the graphic itself handles an animation. I won't go into too many details, but all it's doing is saying, hey, whenever I'm receiving an impulse, I'm resetting the progression variable. I'm checking the impulse type that's coming in to adjust the color. And right now it's only blood. And so then the show pulse is set to true. And that is what triggers the process loop into animating the texture, not texture, but the color of the material. One caveat is that you have to make sure you set the material to local resources, to become a local resource, which means if we go to the inspector and hit up the main scene, let's see, yeah, here we go. So this material here, if I expand it, this resource, I had to say it's local to scene on. And if you don't do that, all the instances that use this script, this impulse graphic script, to process this animation, they're going to use the same shared material, and then they'll just flash and shake at any like triggering of the event across the scene. So, and then similarly, if we've been damaged, we set the progression to true, shake to true, and then I established a little bit of a logic that goes through the progression variable 4 times essentially. This is like, let's see, its duration is there. So yeah, I think if it goes through 4 or 8 iterations, it'll shake that much. And I set up an enumeration for left and right. So if it's left, we just shift it the other direction. If it's right, shift it the other direction. Nothing crazy. It just goes left and right for a little bit, and then we move on. And what's nice about this is that it's all separated from the logic of just the operational logic that I care about. So then if we look at the heart, which is in the scene 3 times, you can see that there's the separation between on ready and enter tree. And what's interesting about this system is, so everything on ready, if we look at the tree, on ready means that it will only fire if all the children of a node are also ready. So in other words, it goes through, on the ready event will fire as you go reverse through the tree. So once all of these fire ready, then body section fires. Once this fires already, this fires, and then these all also just fire. This creates a problem if you don't know about this, because anything that might be listening, let's say that, so right now, the body section that wraps these events, they connect to themselves in a similar way as before, listening for register events. So basically, whenever I add organs to a body section, they all fire a registration event on ready. And the reason why this is on enter tree is because these fire in the order that they're added to the scene. So basically, on the way down, all the things get listened to if you do that on enter tree. And then on the way back up, on the on ready events, they can fire knowing that, well, they can fire and then the parent will know to listen before they fire. There was a moment there where I wasn't sure why my events weren't being listened to, but it's because they weren't listening to it until the children were done being ready, essentially. So it's a pretty cool convention on enter tree. If you're doing this kind of self-listening scenario, then just making sure that these sit in enter tree and then nothing else works pretty well. So in other words, when ready, we met the register. When we register on the impulse graphic, the body section, what happens is we just add to a role denominator. I gave each organ a space property. Space being how much space they take up in the body, which represents the chance that they'll be hit by an attack. So then, let's say, so right now I have a heart set to space 1, bone set to space 1. The bone in this case I'm representing as the rib cage. So let's just say there's a 3 times higher chance to be hit than this. So that's the way it works. So we add 1 plus 3, and then when we go to calculate how much of a chance heart has to bone, we say, hey, well, 1 over 4 is 25%, 3 over 4 is 75%. So right now the heart has a 25% of being hit, and the bone has a 75%. So going back to this, when we trigger the on damage state, basically whenever damage is hit, both the bone and the heart will fire things up. And one improvement I think I can make in the future is just having a class that every part of the body extends from, maybe, because they have similar things. Like they both have integrity, they both have space that is exported, they both have the damage and damaged, and they both have this internal graphics. So maybe there's a different term I can use as a basis, and then maybe the heart pulsing is an optional aspect to that as well. Regardless, the next thing is what happens whenever an organ is damaged. And here I found that there's a random float function which just produces a value between 0 and 1, which is good enough for my purposes. I start off on 0 on both the from and to as I go through the loops to see when a roll is hit. I loop through all the organs that are in the array. What I like about this structure is that it could even make it to where during runtime, you can imagine like maybe some kind of monster with like maybe like a hydra. You could have a head and a neck, and then maybe that structure gets destroyed, but as a result of that, it produces a copy like times 2, so that you have 2 heads that come in the place of the 1 head. And then those would just automatically get added to the hit list here. And the chance to hit one of those changes appropriately. It's probably not good for resources. It's not probably not the most efficient, but it sounds fun to me, so I'm going with it. Now we go through and check to see if the roll denominator is less than or equal to 0, meaning that there's no organs to roll on, so there's no point in doing anything. I probably should put a break in here. But right now I'm just messaging, hey, everything's destroyed essentially, so there's nothing else to do here. We get to here and I check to see if the current organ has any space, because when an organ is destroyed, we find the organ index in the organs array here, and we check to see that it exists in the array first. And if it does, then the roll denominator just subtracts the amount of space that it takes up, so that you're not hitting something that's already destroyed. And then the organ's space is set to 0 inside of the array. And that way I don't have to remove it from the array. It just is there at a 0 chance of being hit. So then we get to here, and that's why this is, if it's 0, we just move on to the next organ. Now, right. This is probably a bug now that I think about it. But we'll move on. It has the same general effect. So basically, it has the same effect because 0 being added to the end of the range doesn't do anything. So that's why it works just fine. So otherwise, we extend the range from 0 to the previous from starting spot to that 1 divided by 4 if this was the rib cage. 3 divided by 4 if it's the rib cage, 1 divided by 4 if it's the heart. So then we go down, I do a print to make sure I can see what the roll looks like and if it's in range or not. And if we're inside that range, inclusive on the front end and exclusive on the other end, we then print that we've hit it, what organ got hit. We emit the damage signal on that organ, which it is currently listening to. This subtracts, and then it lets everything know, hey, I've been damaged, and if I've been destroyed. Then we move on to the next organ, assuming that if we've been hit, we just kind of stop and move on. The next one is if it doesn't reach it, we just increase the from range to the current 2 value. And then the next loop, it increases the 2 range to the next roll denominator block so that we can roll within reason. And that's pretty much it. Yep, that's pretty much it. So another technique I've been using here is starting with the simplest thing, adding functionality, and just kind of copying and moving on as I go. My hope is that eventually you just see a progressive evolution of functionality as we keep going to the right here. Because I find that it's pretty overwhelming to try and do everything at once. So that's the thing. So I'll go ahead and hit play here. So as you can see, damage, red pulse, the heart's still working. The rib is taking damage. You can see here, hit bone, hit bone, hit bone. And you can also notice that as damage gets taken on the heart, the beats go down to 0. So now this is taking damage. You can see how it's coming out of sync with the normal heart. And then as it approaches 0 integrity, it loses the ability to beat. And that's because the animation frames go off the integrity value. So as you can see, we have 2 destroyed objects here, boom and boom. And then the heart itself, which I thought was pretty elegant. So when we process the frame count, I'm using the integrity value instead of just like 1. And so basically as the integrity goes down, the frame count increments more and more slowly. So the signal to impulse happens farther and farther apart. So as you approach 0, the farther apart the beats are, and as you hit 0, no more beats. So that's the gist of what I've got going so far. I appreciate you watching. I hope this was interesting, and I hope you have a nice day.